Hello everyone, welcome to my video on the etracer project, the vacuum tube curve tracer. So today I'm going to show you the measurement result on some really sensitive tubes like 12AX7. So I've introduced this to you guys before. When designing this kind of test equipment, there are like two extreme cases for the equipment to support. One extreme is you have to support really high current, very high voltage on powerful tubes like output tubes like KT88, 300B, or even a transmitting tube like GN70. So the other extreme is that we have to provide the reliable result on really sensitive tubes like 12AX7. Here we are dealing with like a mini amp or even a fractional mini amp. So it's quite challenging, and the noise is really an issue. So fortunately, the theory of stochastic communication tell us that if the noise is Gaussian type, white Gaussian type, we can use average to improve the SNR. Or even the noise is not Gaussian, the central limit theory tells us if we have enough random variables, the central limit theory says the noise will be Gaussian-like, so we can still apply average. So today I'm going to show you the how with the help of averaging we can achieve a reliable result on 12AX7. So here I'm going to show you the firmware of etracer. So currently so this part of code is performing the measurement, doing the average. So as you can see, I'm the average 32 times now, and so the shift is 5 bits, so that gives us a division of 32. So let me build the code and download it to the target. Okay. This is the software, so I'm going to launch the etracer software. So here we can download the tube configuration data. So I'm going to download this 12AX7 configuration file, and the file will configure the software properties. So this orange line is the power dissipation currently set to 1 watt, and here is the step we are going to use for the measurement. Okay, connect and run. So here you can see the curve is it's not very linear, not very smooth. You can see a lot, it's very bumpy. So this it's because the board I built is there's so many like jump wires, so the board itself is very noisy. The ground plane is not clean. So this is a consequence of it. The signal is quite noisy. I also improved the measurement speed by tracing the curve both ways. It really speed up the measurement. So, and I'll make it it's a switch this function switchable in the software. Okay, so this curve, I mean, we can see the behavior of the curve, but it's ugly. So let's quit the measurement and use a different setting of average. So now I'm going to 256 times average. So that's a shift of 8 bits. And change this guy to 256. Okay, build it. and download it. Okay. Okay, now let's rerun the Python code. Load the tube data, connect, and run. So now you can see the curve is much better. It's much smoother, and I hope you like the tracing speed. I think it's very acceptable. We can complete the curve tracing within 1 minute. Okay, here is probably another problem I need to solve, but it's not that important at this moment. It looks like there is a DC drift, like measurement drift here. So I think we perform some calibration, and we can resolve this problem. So as you can see, the curves are usable now, and we can derive the gain, the impedance by using these data points. And this is only 256 times average. If we modify the software, I can provide even more average. So I'm thinking doing a 1024 samples average, for example, and that will provide a much smoother measurement result. Okay, so thanks for watching my video. This is the current status on the etracer. I'm working on the filament supply. I just ordered parts from Taobao, which is like eBay in China. So once I get all the parts, I try to put the heater supplier together, so we'll have a complete solution. Okay, thanks. That's it. Bye.